Hello, everyone, and welcome to another Ask the Experts session on LearnTV. My name is Lanisha Vaz, and I'm super excited to be here today. Today, we'll be diving into the world of healthcare, and more specifically, healthcare data. We'll talk about things like data interoperability and the fast healthcare interoperability resources, or FHIR, and the Azure API for FHIR. Joining me today to talk about all of these topics is Doug Seven, Senior Director of Microsoft Health Next.
Hey.
Thanks for joining us today, Doug.
I'm glad to be here.
So I wanted to talk to you about FHIR, which we've been hearing a lot about. And really, I think a great way to start off with this is for you to just tell us what is FHIR and why should anyone in the healthcare space, particularly developers, why should they care about this?
Yeah, great place to start. I think, if you're a developer in health IT or working on healthcare platforms or solutions, chances are you've had some exposure to FHIR. You've probably heard of it, but we're finding still lots of people aren't really aware of what it is. So FHIR, like you mentioned, the Fast Healthcare Interoperability Resources, FHIR, pronounced FHIR, is a specification that defines interoperability of healthcare data. So the specification was designed to sort of by a cross industry, if you will, set of organizations. Like they came together to form the specification and essentially solve the problem of how do disparate organizations that are dealing with healthcare data exchange and share that data in a meaningful way, whether it's from one healthcare provider to another healthcare provider, or from a payer to a provider, or even to a patient. How do you exchange that data sort of consistently in a way that everybody can understand it and use it, and do it in a way that makes it systematically acceptable, that I can build applications that understand that data and use that data. And so it's a little bit analogous to something like Bluetooth or USB that we're all familiar with in our daily lives, where a specification was created that said, if you want to build a device that connects over Bluetooth, just implement this standard and then it'll work. And so FHIR is basically the same thing, but for healthcare data. If you want to exchange healthcare data, just make sure that it's defined in the same format and is exposed in the same way, and then we can exchange the data. So, for example, Lanisha, if you and I were each building our own systems and we wanted to exchange healthcare information, if we both implement the FHIR APIs that are defined in the specification, we can send data back and forth. And as long as that data follows the same structure, that we've defined everything the same way, then we can exchange that data. Now, in my system, I might do things differently, and in your system, you might do things differently, and that doesn't matter. It's really about the interoperability. And so the specification just says, look, here's, roughly speaking, 120 different, what they call resources or entities, like patient, procedure, practitioner, observation, medication, so on and so forth. There's about 120 or so of those. That are defined that says, okay, well, if you're going to talk about a patient, well, a patient has a name, a patient has a gender, so on and so forth, has all these things. And as long as we agree on that definition, then I can send you my patient information and you can receive it. And so that's really what FHIR is. It's just defining a standard for the exchange of data between two entities.
Right, and that makes so much sense, especially when you use the USB analogy. That makes a lot of sense in how you would exchange data, but in a common standard, so that you and I, as you said, can be using the same kind of data in different formats in our systems, but then we bring it together to exchange in a common standard. So what is your team, or what is Microsoft really doing while engaging with the FHIR standards and building for it? And how are you making sure that developers have what they need as they're going forward to build for this?
Yeah, so my team is part of what the group is called Health Next, and we're part of Microsoft Technology and Research. And our job is to incubate new technologies and particularly focus on healthcare, and where we think Microsoft, with our technological capabilities, can bring an advantage to the industry or to the organizations using the technology to do something meaningful. So in this case, our team has some legacy in this space in terms of working with things in the past like Health Vault and the band and the services associated with that. So we have a sort of a lineage, if you will, in the healthcare space. And we were watching the sort of development and emergence of the FHIR specification as it was growing. And a few years ago, maybe 3 or 4 years ago, we started to really look closely at it and say, this it looks like something we're willing to bet on. We think that the FHIR specification will continue to gain a momentum, and eventually will become the de facto standard for how data is exchanged, because it makes sense. It's kind of like looking at some of these other things and you go, yeah, that makes sense. We should do that. So a few years ago, we essentially made a bet on FHIR and said, look, if we can enable Microsoft technology, whether it's our Azure Developer Cloud technology or the M365, cloud productivity technology, Dynamics 365, whatever it might be, if the Microsoft technology could understand FHIR and essentially speak the language of healthcare, then really cool things could come out of that. You could, easily bring data from disparate systems into a single cloud environment. You could then connect that into tools for things like machine learning and analytics and do some really cool things. You can connect it into other platforms like Dynamics or M365, where, you think about coordinated care scenarios and new patient engagement scenarios and all these kinds of things that the organizations that we work with really want to do. And so, this was all about how do we make that possible? How do we make it easier to do this? And the interesting thing about going through the process of building a healthcare service, a service that is solely designed for healthcare data, the Azure API for FHIR is exactly that. We just took the FHIR specification and implemented it as it was written. We didn't really apply any opinion to it. We just said, look, if this is what the specification is, let's implement it as truly as we can. So then if you have a system that can work with FHIR data, you can connect to the Azure API for FHIR. You can bring your data into the cloud. And then, like I said, all of a sudden it becomes possible to, I want to export that into Synapse Analytics and do something cool with it. I want to export that into Azure ML Studio and do something with it. I want to connect that to Dynamics and build a new engagement platform. Lots of really cool things you can do with it. So that was really, for us, a great endeavor to focus on something that was so specific for healthcare data and build something that would give people the potential to do something really powerful with healthcare data.
That's fantastic. And as I understand it, you have your managed service that is the Azure API for FHIR, but your team also releases things in open source. And what is sort of your thinking behind that? Does it allow developers to use the open source first and then kind of learn from it?
Kind of. That was part of the reason. The primary rationale we used when we started the team was we wanted to engage. We didn't want to just build a FHIR server. We could read the specification and build a FHIR server, but we really wanted to engage and become part of the community that was helping to advance the use of healthcare data, for whether it's for primary care or for research or whatever the different scenarios might be. And so when we looked at FHIR and said, okay, well, this is an open specification being developed by a community of people, we too should participate in a meaningful way. So let's build and release our implementation of that as an open source project. So then not only can you see everything we're doing, but if other people want to contribute to it through the open source channels, they can. And then we take that open source code, the same code we have in our GitHub repository is the same code that we run in Azure as a first-party service. We just take essentially a distribution of that open source code and we run it as a managed service, which means there's a Microsoft engineering team behind that service 24 hours a day, running that service, ensuring its uptime, ensuring its capability, building all the compliance controls into it and all those things. So from a customer's perspective, hey, there's an open source version and there's a managed service version. The advantage of open source is I can see what you've done, I can see how it works, and if I want to make a change to it, I can. Even if I want to branch it and do something different, I can. But if I would rather that Microsoft just ran it for me and handled all the ISO compliance and all the HIPAA compliance and the high trust compliance and distributed it to different regions around the world, Microsoft go do that for me, then we do that too.
Got it. Okay. That makes a lot of sense. And I think you brought up a really interesting point when you talked about HIPAA and compliance. So that's a really big deal in the healthcare world, especially with healthcare data, which is protected health data. So how do you tackle the compliance and things like the HIPAA safe harbor guidelines when you're working with this PHI data?
Yeah, there's really two parts to the question there, which is how do we deal with compliance, and then how do we think about secondary use of healthcare data, or how do we enable secondary use of healthcare data? On the first part of that question, one of the sort of core principles of our team is that we are building a service that is exclusively for protected health information. And so we have to, from the very beginning, be thinking about how do we ensure the safety and security and privacy of protected health information. So things like ISO certification, HIPAA compliance, high trust certification, these are all tools that are designed to validate that we've done the right thing. So it's a way of communicating to our customers an element of trust. We've been certified by a third party that we're doing all the right things, so you can trust that we're taking care of your data. But just know also that from a very principled perspective, it's something that we believe in from the very beginning. So we're always thinking about the fact that this is extremely sensitive information, and we have to make sure we're doing all the right things to manage it. That's true of all Microsoft services. We have a culture of thinking about that. Trust is very important to us. But in this particular case, because we're exclusively dealing with protected health information, it's really at the top of the stack in terms of things that are important to us. The second part of your question is interesting because HIPAA defines some rules around what you can do with healthcare data. And there's this concept of primary use of healthcare data, which is the use of healthcare data for the direct care of a patient. So if I'm a practitioner and you're my patient, any data I'm using to care for you is important. So if I'm looking up your allergy information, so I make sure I give you the right medication, that's all primary care. If I want to do research using your data, if I say I want to take your data and I want to do some machine learning on it, or I want to do some analytics on it, or I want to combine it with data from other places, or maybe some social determinant data and do some research with that, that's considered secondary use. It's not for your primary care, it's for some other reason. It could ultimately benefit your care in the long run, but it's really secondary. And so HIPAA defines some rules around the secondary use of data, and that data has to be de-identified sufficiently. So as a researcher, I can know about your allergy information or your medication history, but I shouldn't know who you are. I should just know that you're a person, and maybe I know your gender, and I know generally where in the world you live, but I don't know specifically who you are, or specifically what your birth date was, or specifically what your address is. And so we've implemented some capabilities in the FHIR server that put some controls in your hands to de-identify the data. And the HIPAA privacy rule describes two forms of de-identification. One is called safe harbor, which is basically a redaction of anything that could be potentially identifiable. And they define 18 different attributes that would be, and the 18th one is anything that could be identifiable. So it's leaves it a little bit open. But it's, name, birth date, social security number, phone number, stuff like that. So we redact all that stuff. And then things like medications and procedures and all that get retained. There's also this concept of what's called expert determination, which is maybe I don't redact everything. Maybe I replace some values, or I encode some values, or I shift like dates, for example. Maybe I shift the dates. And so the data is still there, so I can use it in things like machine learning and analytics where I might need that data. But as the researcher, I can't use that to identify who you are. And so the way we've built the de-identification capabilities into the FHIR server is that there's a configuration file that you have control over, and you can decide what kind of de-identification you want to use. Do you want to redact? Do you want to crypto hash? Do you want to date shift? And so you get some flexibility in what you do there. And expose yourself to some level of control over the de-identification. And then if you're doing that, then then becomes your responsibility to do the expert certification. You get a statistician to say, yes, for this use case, for what you're doing, this is considered de-identified sufficiently.
Got it. Okay. So I've also been reading about the ONC Cures Act and how that is bringing, or so rather is accelerating the adoption of FHIR. Can you tell us a little bit about what that is and what it really is going to help do in the industry?
Yes, and I won't point out the pun of accelerating FHIR, putting an accelerant on it, but, although I just did. So the ONC, the Office of the National Coordinator for Health IT, is responsible for a bunch of the legislation around health data and what happens with it. And the ONC has something that is referred to as the final rule. And this is in relation to the Cures Act, which was introduced a while ago. And the final rule is an update to the Cures Act. And it was just recently finalized. The final rule is finalized. And what the final rule is about is predominantly it's about patient access to data, to your own healthcare data. And it's about information blocking from one organization to another So what the Cures Act final rule is trying to solve for is you as a patient have a right to access any data about your healthcare. So any procedures that were done, any diagnoses that were made, you should have access to that data. You should also have the freedom to go to any provider you want. And so if you go from one provider to another, you should be able to bring that data with you. Either you can bring that data and give it to the new provider, or the provider can get it directly from your previous provider. And there are cases that this wasn't happening as easily as it should have, or even in some cases not happening at all. And so the final rule is really designed to prevent that level of what they refer to as information blocking. So as a provider, if I hold your healthcare data, I now have a responsibility, and this is now the responsibility is put on me through the legislation of the final rule to say, I have to make that data programmatically accessible to you. So in other words, you can have an app on your phone and get that data.
Oh, wow.
And it can't be an app of my choosing. It has to be an app of your choosing. So I have to make that data programmatically accessible to whatever app you want to use to get that data from. And I have to make that data available to any other provider that is involved in your primary care. So if somebody needs that data, they can get access to it. There's a number of reasons why this is important, but you can imagine things like simply just having your information available so that when you're getting care, you're getting the best care possible. But even things like you can imagine as a patient, if the provider that you're working with had access to your data through your insurance company, for example. Your insurance company maybe paid for a blood test recently. And the provider you went to go see wants to give you a blood test because there's some information they need, but they can see from your records that you just had a blood test. So then they can say, okay, now rather than sticking you with another needle and making you go through this process again, I'm going to go request the information that was, gotten in that blood test from the other provider and get that data. So there's a real valid reason for all the sharing to happen. And this is why the ONC is trying to stop this level of information blocking. And so they've introduced the legislation in the final rule that says patients have a right to their data, providers have a right to the data about the patient. This data has to be available. And in the process of doing that, they defined FHIR as the standard for the exchange of that information. The only way this works is if everybody shares information in the same format. So they've said, look, you have to use FHIR. You have to have FHIR APIs. This has to be available.
Right.
A right to get to their data.
Wow, that's going to make a huge difference, I think, to a lot of consumers like myself, but also like, as you said, providers who are having that issue.
And it's very much designed to benefit the patient. It's really patient-centric, but it forces any organization dealing with healthcare data to essentially do the right thing.
Right,
by the patient.
Yeah. So as you're talking about a lot of this healthcare data that we're seeing, and I would imagine that sits in a medical record of a patient at a provider or say in a payer as well. But what about other types of data that are involved in healthcare decision making? So I'm thinking of like a CT scan or an MRI. So what would be imaging data? Does that fall within the same paradigm of FHIR, or how does that work?
Yes and no. There's a big part of the FHIR community that's thinking about the connection of imaging data with FHIR data. So FHIR is really designed around the sort of clinical medical record. So it's text data, and there's a part of the FHIR specification that they define what they call an image study, which then can reference a DICOM. If you had an MRI or an ultrasound or something like that, there's what's called a DICOM instance associated with that, which is all the images that go along with that, and any markup that maybe a radiologist did on the images and things like that. So there is in FHIR this concept of an image study, but mostly it's a little bit of metadata about the image study and then a pointer to wherever the image study might be in some other system. And that's good and that's important, but what's really important is what we found from talking to different organizations is the ability to bring those two data together, to have them be represented in one common system. Some of the early questions we got when we started talking to people about building a FHIR server was, hey, that's really great. Here's the scenario. This is what I want to do. And they would say things like, oh, I want to find all the patients in my system that have a particular condition, that are on a specific medication, that are over a certain age, and that have had 2 MRI scans in the last 12 months, and I want to see their medical history and their MRIs.
Yeah, that's really specific.
It's really hard. And in some cases, the only way you can do it is if you can bring those two systems together. I need information from the DICOM, from the PACS system. I need information from the EHR. And so one of the things we announced back in November, kind of following on on the path we led with FHIR, where we said, hey, we're going to release something in open source so everybody can see it, particularly when it's around an open standard. But the intent is to bring it into a managed service at some point. We released what we call the medical imaging server for DICOM, which is similar to the FHIR server. It's an open source implementation of a standard, in this case, the DICOM standard. DICOM defines what they call DICOM Web, which is a web-based API similar to FHIR. So it's a RESTful API interface you can access over HTTP. And you can use that to do CRUD operations on DICOM instances. So I can build up a server of all my DICOM instances and all the data that goes with it. One of the novel things that we did as we were thinking about these challenges that some of the customers were telling us was we built something called DICOM Cast. And what DICOM Cast does is as a DICOM instance comes into the server, we capture and extract the metadata and pipe that into the FHIR server so that the data for whatever's in the DICOM server is also in the FHIR server, which means that then I can just query the FHIR server for what I need. I have everything I need there, but I also have an access point into that DICOM server. So some really fascinating stuff where we're able to start to show some of these use cases where we could connect a tool like Power BI, which is this amazing visualization tool for data, connect it right to a FHIR server and show all of this data, including what was in the DICOM server, which is really fascinating.
Yeah, and that's probably starting to answer some of those questions that your users had and trying to work towards those. That's fascinating.
Exactly.
Now we have a question from one of our listeners. Dustin wants to know about how, with the changing landscape of care, how particularly in the past few years, people have started to move towards virtual care and remote monitoring. They don't really want to come into the hospitals and stuff. So how has device-led care, almost like Internet of Medical Things, is that something you're thinking of and building into the API for FHIR?
Yes, there's two parts that I want to talk about. One is this concept of remote patient monitoring, which over the last few years has been an area that has been getting more and more attention, with the sort of easy accessibility to remote devices, things that I can wear on my body that will listen to my heart rate or check my pulse or my temperature, even check my mobility. Everything from like I said, our team used to deal with band services. So even things that were lifestyle, that were originally designed as lifestyle devices, but eventually became something that I could use to monitor sleep. I could monitor, like I mentioned, heart rate and things like that. There's a real need in the healthcare space to be able to monitor patients after they leave the clinical environment. Oftentimes you can come in and I come into a clinical environment for some acute thing, but the only way it's really going to get better is through long-term monitoring or even just short-term but sporadic monitoring. And so this idea of remote patient monitoring, where I'm going to put a device on somebody and I'm going to either continuously stream data from that device, or maybe once an hour or twice a day I'm going to get a snapshot from that device, whatever it might be. So Azure has an IoT platform, and what we've done is we've sort of built a little bit of an extension on that platform that we call the IoT connector for FHIR. And what this does is it enables these device companies to leverage our IoT platform and all the device management capabilities and things that come with that. But then we have a sort of step in the process, in the workflow, where we listen to the telemetry stream and we can map the data coming from the telemetry stream into FHIR resources. So if it's things like heart rate and temperature and whatever other monitoring I want to do, I can convert that easily into a FHIR observation, and I can put that observation in the FHIR server along with the rest of my medical history. So now as a practitioner, as a provider, one use case might be that I have a dashboard, a screen where I can see my patient, I can see their recent observations and their recent treatments, maybe their medications and all those things. But I can also see the real-time biometric data coming in and say, I can see their temperature is slowly increasing, or their mobility is decreasing, or they're not sleeping as well, whatever it might be. And then I can make a decision to intervene before they even know they need to come in into the clinical environment. So this is huge for healthcare providers. Really, this is how they can kind of extend beyond the clinical environment and really reach patients where they live and where they do. The other piece I wanted to mention on that was not as much device related, but you mentioned sort of telehealth, like, especially with all the things we've seen with COVID and what's been happening there, this need to be able to connect a patient and a provider without physically being in the same place. One of the things we announced kind of at the end of last year was what's called the Microsoft Cloud for Healthcare. And part of the Microsoft Cloud, the idea behind the Cloud for Healthcare is to bring together all of these things that are relevant to healthcare scenarios. So using Dynamics to create patient engagement tools, using Teams for telehealth. I want to have a video conference with my provider, and I want to do that in a secure way. And I want them, while they're in that environment, to be able to see my medical history. So I want to integrate all that stuff together in Teams. So the idea that we can have this data coming in to a service in Azure where it's available in all these different tools, but also then connect into Dynamics and connect into Teams and M365 means that organizations working with healthcare data have this much larger surface area of things that they can do. It's no longer that I have to, schedule an appointment and find a different tool to use to have a telehealth conversation. I can do it right in Teams, and I can pull that medical data right into the Teams environment, which is fantastic.
That sounds super powerful because, what you're saying is you can go right from viewing a patient's data to scheduling a call to like looking at all of the data of your patients in probably a hospital or something and kind of viewing them against other patients. So that would be super helpful for providers. Yeah. So I just have a quick last question for you before we wrap up. And that's, what are sort of the challenges you see customers are facing, organizations are facing, that you think the API for FHIR can really help with?
It's a hard question to answer because it's very broad. We tend to think of our customers as being in we sort of categorize things of, are you a healthcare provider? Are you a healthcare payer? Are you a pharmaceutical company? Sometimes those lines are really clean. Sometimes they're a little bit blurry. But the challenges can be very different about whether or not I'm trying to, for instance, we were just talking about Teams. We have a healthcare provider on the East Coast that was building a Teams interface for their care teams to be able to ask questions through Teams so they could use natural language and things like that. But then those questions would get routed through Azure search capabilities and into the API for FHIR, so they could say, when was the last time Lanisha had a blood test? And then that would turn into a FHIR query and ask the medical record that question and get that data back. And so for the clinician, it was a really natural experience and a really natural interface, but it tied right into that API for FHIR. In other cases, we've seen healthcare payers looking for ways that they can use machine learning to analyze data to find better ways to sort of optimize how people are doing things from a payer's perspective, with the intent that they, what the goal everybody has is to drive down the cost of healthcare and make it more efficient, make it effective, and bring it down. So whether that's through finding ways to communicate to providers that procedures have already been done and you don't need to do them again, or if it's fraud or whatever it might be. So lots of use cases.
That's awesome, and it sounds like there's really so much application for FHIR, and especially as you're building and developing the Azure API for FHIR with the ONC's rule, this is going to get really more and more popular, and almost is going to just, as you said, accelerate the adoption of FHIR. So, well, this has been super informative. I've learned a lot, and thank you so much, Doug, for joining us and taking us through this this chat about interoperability, FHIR, and the Azure API for FHIR. Thank you.
Thank you.